then they are supplementary. Okay, inverse. If two angles do not form a linear pair, then they are not supplementary. All right, let's do the truth value of both. The original. If two angles form a linear pair, then they are supplementary. True or false? Everyone type. The original, the original. True. That is actually called the linear pair theorem. All right, now the inverse. If two angles do not form a linear pair, then they're not supplementary. True or false? These not ones are hard. Good, it's false. Because I can draw two angles that do form a linear pair. No, sorry. I can draw two angles that are supplementary. Look at those two. They are supplementary, but they do not form a linear pair. Linear pair means they're adjacent to each other. Okay? So that's why the original is true and the inverse is false. Next one. If an angle is not right, then it is acute. Write the inverse. What happens in algebra when you have like this? What does that equal? What's a negative negative 4? It's a positive 4. The negatives cancel. So the same thing happens with your knots. If an angle is not right, well, the inverse of that is, you don't write, if an angle is not right. Yeah. Oops, that's my F. Okay, if an angle is right, because a not is an is, then it is acute. Okay, truth value of the original. If an angle is not right, then it is acute. No, because it could be obtuse, it could be straight, it could be a reflex angle, so that one's false. Truth value of the inverse. If an angle is right, oops, I didn't put my knot. Okay, y'all are probably telling me that. Sorry. I just now read the sentence when I turned around. If an angle is right, then it is not acute. If an angle is right, if it's a 90-degree angle, could it possibly be acute? It could not be acute at all, so that one is true. Sorry about that. I did not write the word not. I fixed it. Cool? A not is an is. They cancel. All right. So, I don't want you to think that we're going to be writing full-blown proofs today, but we are going to take baby steps. A big part of geometry is backing up the steps that you do, the decisions that you make. When you set two angles equal to each other, you're doing that for a reason. You're doing it because of the angle, maybe because of the angle bisector theorem, or maybe because definition of congruent angles, or maybe you're doing it because they're vertical angles. When you perform mathematical operations, you're doing them for a reason. And it's important to be able to back up that reason, to be able to justify the reason. So you can informally reason through something, and you can formally reason through something. So if you're going to do a formal proof, it would be flowchart, paragraph, or 2-column. We're going to start with 2-column in this class. Informally just means, just justify your answer. Just back up why you did that, okay? So we're going to start with informal. We're going to decide if it's true or false, and then we're going to try to use some reasoning or just informally back up what we say is true, okay? Okay, everyone's saying false. If an angle is acute, then the measure of its complement must be greater than the measure of its supplement. That's just craziness. That's just a weird sentence. But we need to say false, and then we need to back it up, okay? So we know that it's false. That's great. But we can't always just get away with writing our answer. Sometimes we need to explain it. So if an angle is acute, we're going to name that x again. And remember, if it's acute, x needs to be less than 90 and greater than 0. Not equal to 90, right? Because if it's equal to 90, it doesn't have a complement. Yes, you can prove by substituting numbers. Yes. And that is one of the properties on this list that we're going to get to. Okay. But we're not proving this. We're just backing it up. This is informal. Okay? Okay. The measure of its complement, so there's the measure of its complement, must be greater than the measure of its supplement. Now, if I were solving that equation, if I were trying to solve for x, what would I do? What would happen to those x's? You have a negative x on the left and a negative x on the right, and so when you add x to both sides, they're going to cancel. They're going to be gone. Well, since when, that's left over. Since when is 90 greater than 180? Never. So I would say that's a false statement, and after we did all the algebra, we realized that's false because 90 cannot be greater than 180. So that would be like our explanation. 90 cannot be greater than 180. So we showed it algebraically, we explained it with a sentence. That's informal. Yeah. Next one, a pair of vertical angles could also form a linear pair. A pair of vertical angles could also form a linear pair. This one we're going to back up using the definition of these words. Definition of vertical angles, definition of linear pair. Good. So we know that this one's false. And we could write out a long sentence, and I could type it out. Here's what I would write if I were really writing the long sentence. By definition, vertical angles are the opposite angles formed when two lines cross. By definition, angles that form a linear pair are adjacent, and angles that are opposite cannot be the same as angles that are adjacent. So if you're proving informally, you could draw a picture, you could call on the definitions, you could write a sentence. There's all different ways if you're informally just showing that something's false, okay? So the easiest way to put that is you can't be opposite and adjacent at the same time. So that's my summing it up as short as I possibly can. Okay. If a ray divides an angle into two complementary angles, then the original angle is a right angle. True or false? This is absolutely true. This is absolutely true. If a ray divides an angle into two complementary angles, it didn't say congruent. It says if it divides it into two complementary angles, then the original angle had to have been a right angle. And we would back that up with the definition of complementary. To be complementary angles, they have to be two angles. We'll just say, we'll call them x and y. So if a ray divides an angle into two complementary angles, then the original angle, that original angle had to have been a right angle because x plus y equals 90. They're already adjacent to each other because it's one ray dividing an angle into two complementary angles, any two angles. So they're adjacent and they add up to 90, so that original angle would have had to have been a right angle. Okay? I think y'all were getting complementary and congruent mixed up. Alrighty. Here's what a two-column proof looks like. We are now going from informal, oh, just back up what you say, to formal. We're going to do it in a certain way, like where there's only one right answer. Okay? Like we're used to math being, right? Okay, so when you do a two-column proof, which we're not going to do a full one today, you always start with given information, and you always end with what you're trying to prove. And as you go through your reasoning, you back it up with the things on this sheet right here. This is your backup. I got your back. This is the sheet that's got your back. Okay? These are the definitions, theorems, properties, and postulates that you've learned so far this year. You've learned all of this. Woo! You've learned all of this. Now, 1 through 9 you learned in algebra, but 10 through 23 rather, you have learned all of it this year. Okay? No, you don't have to use eloquent language. So we can back up what we're saying with theorems, we can back it up with properties, we can back it up with definitions. So we can use any of those. Those are all at our disposal. Here's what a two-column proof would look like. This I got from your textbook. Your textbook loves to prove things. But what we'll do for a long time first is just have fill-in-the-blank ones. Let me show you how this would work. No, you're not going to do a two-column proof today. And no, you're not going to do it on your homework. And no, it's not going to be on the angles test. But it might be on the next test. Okay, but I want to show you how it works. So, in a two-column proof, it's pretty easy when it's fill-in-the-blank. You always start with the given. Look, the given is angle 1 and angle 2 are right angles. So guess what goes in the blank here? Angle 1 and angle 2 are right angles. All I did was rewrite the given. What's the reason? Oh, that's easy, given. Okay, next. The measure of angle 1 equals 90. Well, now I have to kind of go to my list and decide what one of these things is going to back that up. I said that they're right angles. Now I'm saying that the angle equals 90. Well, that is a definition. By definition of a right angle is an angle whose measurement is equal to 90. What would I say next? Well, I said angle 1 was 90. Now I need to say that the measure of angle 2 equals 90. And they already wrote for us definition of right angle. Okay, here's the important part. Now, I'm going to say that the measure of angle 1 equals the measure of angle 2, because they both equal 90. Do you know which property that is right here? Oh, the list is on the calendar, Nathan. No, for number 4, it's going to be 1 through 9. It's going to be one of those. If A equals B and B equals C, then A equals C. If the measure of angle 1 is 90, and 90 is the measure of angle 2, then the measure of angle 1 equals the measure of angle 2. It is the transitive property. It's number 3, transitive. And then guess what the last row always is every time? It's the prove. So I don't even need to make this up. Angle 1 is congruent to angle 2. I stole it from right here. And what's the reason? It's the one y'all all wanted to say. It's number 14, definition of congruent angles. But they already wrote it there for us. All right. Like I said, don't look too much into that. We are going to take baby steps. A kid doesn't just like go from being born to start running, right? We're not going to start running yet. We are going to take baby steps. All right. So I'm going to give you the given. You need to come up with a conclusion, and then you need to back it up. You can't just back it up with your own words. You need to back it up with something from the list, the master list. Okay. Angle day and angle yak are a linear pair. So you're looking here, and you're looking at what it says about linear pairs. Do you see something that talks about linear pairs? Number 23. What does number 23 say? If two angles form a linear pair, well, that's given. That's the hypothesis. What's the conclusion? What's the conclusion? On this sheet, what comes after the comma? Good. If they form a linear pair, then day and yak are supplementary. What is the y? What's the y? Linear pair theorem is the y. You have to use a theorem, a postulate, a definition. This is not when you use your own words. This is not. This is formal, and so you need to use something that has already been discovered by a mathematician, something listed here. Next one, given. What do we know about those angles? What do we know? They are vertical angles. You know what? For our class, we're going to just count that in the given. Okay, guys, y'all are all saying number 20, but I want to know what the conclusion is. What comes after the comma? What's the conclusion? Good. The conclusion is angle 1 is congruent to angle 2. And what is the y? Vertical angle theorem. Never on a homework or a test are you allowed to just put the number on this sheet. You have to actually state what it is, whether it's a definition or a postulate or a theorem. Okay? So the conclusion is angle 1 is congruent to angle 2. Guys, you do this conclusion in your head. Y'all already do this, but today we're formally backing it up. I know that if I give you two angles, in your head, you already know that those are equal. You're already putting arcs on that picture in your head, but now we're writing it down. What you're doing in your head, we're actually writing it down. Next one, given the measure of angle nat plus the measure of angle wed is 90 degrees. If that was handed to us, what would we conclude? Yes, Anas, yes. Good. We would conclude that angle nat and angle wed are complementary angles. And what is the y? This is not a theorem. Good. This is not a theorem this time. This is definition of I'll write it out this time because I would expect you to write it out on a test. Definition of complementary angles. Okay, so that one was a definition, wasn't a theorem. Given the measure of angle A equals the measure of angle B, look, I already gave you the conclusion. Angle A is congruent to angle B. So what allows us, what theorem lets us go from equal to congruent? Why are we allowed to do that? Which one? Stop typing numbers. What would you type? What would you put in the y? It lets us go from equal angles to congruent angles, or congruent angles to equal angles. Good. It is number 14, but in the y we would write definition of congruent angles. And that lets you switch back and forth and back and forth. Equal to congruent, congruent to equal. You would write, if it was segments, you'd write definition of congruent segments. This was just definition of congruent angles. Last one, guys. Promise, last one. Then I'll let you practice. Given the measure of angle C is 90 and the measure of angle D is 90, then I know measure of angle C equals the measure of angle D. We did this in that two-column proof. No, Leah, you don't. Yes, go ahead, Lily. We did this one in the proof earlier. What is it? No? I have a question. Will we actually write the definition or like the name of it? Oh, just the name of the definition, yeah. You would write, here's in the y, you're writing this column. This column is your y's. These are your choices. This is like your word bank, okay? So the y, this one's that transitive property again. Okay, so in this unit, you will be allowed to use this on anything you need to use it on. You won't be allowed to use it on the test, but the test is multiple choice when I ask you questions about these. So you'll have these in your choices. Does that make sense? So you won't need to use this on your test because I'm not going to make you write it out yourself. You'll be choosing which one is the right conclusion from a list of 4 choices. Is that okay? Why can't we use the right angle congruence thingy? Because that one doesn't fit the given in the conclusion. Do you see on number 17? That's a great theorem, but it doesn't fit what I have on the board. Do you like if the given was angle A and angle B are right angles, then you could use it. But I'm switching from I want C to be equal to D given that they're both 90, and that's the transitive property. Okay?